An emission inventory is an accounting of the amount of pollutants discharged into the atmosphere. An emission inventory usually contains the total emissions for one or more specific greenhouse gases, or air pollutants, originating from all source categories in a certain geographical area and within a specified time span, usually a specific year. An emission inventory is generally characterized by the following aspects: y, the types of activities that cause emissions; what, the chemical or physical identity of the pollutants included; where, the geographic area covered; when, the time period over which emissions are estimated; how, the methodology to use. Emission inventories are compiled for both scientific applications and for use in policy processes. Use emissions and releases to the environment are the starting point of every environmental pollution problem. Information on emissions, therefore, is an absolute requirement in understanding environmental problems and in monitoring progress towards solving these. Emission inventories provide this type of information. Emission inventories are developed for a variety of purposes: policy use, by policymakers to track progress towards emission reduction targets, develop strategies and policies, or scientific use. Inventories of natural and anthropogenic emissions are used by scientists as inputs to air quality models. Policy use. Two more or less independent types of emission reporting schemes have been developed: annual reporting of national total emissions of greenhouse gases and air pollutants in response to obligations under international conventions and protocols. This type of emissions reporting aims at monitoring the progress towards agreed national emission reduction targets. Regular emission reporting by individual industrial facilities in response to legal obligations. This type of emission reporting is developed to support public participation in decision-making. Examples of the first are the annual emission inventories as reported to the United Nations Framework Convention on Climate Change for greenhouse gases and to the UNECE Convention on Long-Range Transboundary Air Pollution for air pollutants. Examples of the second are the so-called pollutant release and transfer registers. Policy users typically are interested in annual total emission only. Scientific use. Air quality models need input to describe all air pollution sources in the study area. Air emission inventories provide this type of information, depending on the spatial and temporal resolution of the models. The spatial and temporal resolution of the inventories frequently has to be increased beyond what is available from national emission inventories, as reported to the international conventions and protocols. Compilation. For each of the pollutants in the inventory, emissions are typically estimated by multiplying the intensity of each relevant activity in the geographical area and time span with the pollutant-dependent proportionality constant, y. The source categories. To compile an emission inventory, all sources of the pollutants must be identified and quantified. Frequently used source categorizations are those defined by the Intergovernmental Panel on Climate Change in the revised 1996 IPCC Guidelines for National Greenhouse Gas Inventories, IPCC Good Practice Guidance and Uncertainty Management in National Greenhouse Gas Inventories, IPCC Good Practice Guidance for Land Use, Land Use Change and Forestry, and more recently the 2006 IPCC Guidelines for National Greenhouse Gas Inventories, those defined in the UNECE Convention on Long-Range Transboundary Air Pollution. Recently the LRTAP Convention adopted adopted a source categorization that is largely consistent with those of IPCC, to replace the more technology-oriented standardized nomenclature for air pollutants used until 2005. Both source categorizations make a clear distinction between sources related to the combustion of fuels and those that are not caused by combustion. In most cases, the specific fuel combusted in the former is added to the source definition. Source categories include energy fuel combustion, stationary combustion, industrial combustion, residential heating, mobile combustion, fugitive emissions from fuel use, industrial processes, solvent and other product use, agriculture, LULUCF, waste. Many researchers and research projects use their own source classifications, sometimes based on either the IPCC or the SNAB source categories, but in most cases the source categories listed above will be included. What the pollutants emission inventories have been developed and still are being developed for two major groups of pollutants: greenhouse gases, carbon dioxide, methane, nitrous oxide, and a number of fluorinated gaseous compounds. Other greenhouse gases, not included in the United Nations Framework Convention on Climate Change: air pollutants, acidifying pollutants, sulfur dioxide, nitrogen oxides and ammonia, photochemical smog precursors, again nitrogen oxides and non-methane volatile organic compounds, particulates and particulate precursors, toxic pollutants like heavy metals, and persistent organic pollutants, carbon monoxide. Where geographical resolution, typically national inventories provide data summed at the national territory only. In some cases, additional information on major industrial stacks is available. Stacks are also called release points, because not all emissions come from stacks. Other industrial sources include fugitive emissions, which cannot be attributed to any single release point. Some inventories are compiled from subnational entities such as states and counties, which can provide additional spatial resolution. In scientific applications, where higher resolutions are needed, geographical information such as population densities, land use or other data can provide tools to disaggregate the national level emissions to the required resolution, matching the geographical resolution of the model. When temporal resolution, similarly, national emission inventories provide total emissions in a specific year based on national statistics. In some model applications, high temporal resolutions are needed, for instance when modeling air quality problems related to road transport. In such cases, data on time-dependent traffic intensities can be used to establish the required high temporal resolution. Inventories compiled from continuous emissions monitors can provide hourly emissions data. How? Methodology to compile an emission inventory. The European Environment Agency updated in 2007 the third edition of the Inventory Guidebook. The guidebook is prepared by the UNECE/MEP Task Force on Emission Inventories and Projections and provides a detailed guide to the atmospheric emissions inventory methodology. Especially for road transport, the European Environment Agency finances COPERT4, a software program to calculate emissions which will be included in official annual national inventories. Quality. The quality of an emission inventory depends on its use. In policy applications, the inventory should comply with all what has been decided under the relevant convention. Both the UNFCCC and LRTAP conventions require an inventory to follow the quality criteria below. A well-constructed inventory should include enough documentation and other data to allow readers and users to understand the underlying assumptions and to assess its usability in an intended application.